Hello everyone. So I hope you are all doing well. I put together our missed lectures 5, 6, 7, and 8 on impacts of climate change on the United States, and this covers essentially all our readings for March 12th through March 27th. So these presentations are flexible. You can do it at your own pace. You can read and listen to my slides at your own pace asynchronously. You don't need to be on the Blackboard during the class time. Each section can be studied individually or as a part of the sequence. Make sure that you read the assigned readings before the lecture or during the lecture. Also follow the syllabus. And then the lecture notes, of course, are not the substitution of the readings. So you want to make sure that you go to the sources as well. And after each section, you would find the discussion questions, not just a couple of review questions to go over the main ideas. Make sure that you also answer them based on the readings and not just this presentation. So our first unit is the scenarios for climate variability and change in the United States. And this lecture is entirely based on the Climate Science Special Report 4th National Climate Assessment. This material is also available on the Blackboard, and you will find 2 volumes of this report. Volume 1 is covering science of climate change, and Volume 2 is covering impacts, vulnerabilities, and adaptations to climate change. And of course, the direct chapter links are available in the syllabus for the chapter for each week. So let's start about what we know already from the meteorological observations about the climate change that has happened in the United States to date. There is a very high level of confidence that the annual average temperatures everywhere in the United States have increased by about 1 degree. It can be a little less, a little bit more, but it's somewhere around 1.2 to 1.8 degrees Fahrenheit, or slightly less, maybe 1 degree centigrade, based on various methods and observations that have been conducted. The surface and satellite data are also very consistent with the way how they're depicted with meteorological data, and we see very significant warming, especially since mid and the end of 1970s, when we have consistent observations both from space and from the ground. The paleo temperature evidence also shows that the recent decade is the warmest over the entire time during the past 1,500 years. And some areas in the United States have warmed significantly quicker. So we see some areas, for example, in the Arctic, in Alaska, we see much faster warming. We see also faster warming in many other areas. And generally, we see more warming in the north and a little bit less warming in the south. But we're going to look at some maps and see more variability. We also know from the observations that the nighttime minimum temperatures rose much quicker than the daytime maximums, and the winter temperatures also rose much more than the summer temperatures. We clearly see it in Michigan. We are losing our winter much quicker. We don't necessarily see the same dramatic changes in summer. So this is how these numbers look on the maps. You can clearly see that the annual temperature has increased everywhere, almost everywhere. But we see more dramatic changes in northern states, in the west, but also in the southwest, in places such as Arizona or Southern California, or in Florida. We also see very significant warming. We see less warming or almost no warming at all in some parts of the US Southeast. And then the situation is more nuanced if we look specifically at the winter temperatures and summer temperatures. You can clearly see that we experience everywhere much more warming in winter and somewhat less consistent geographic pattern in summer, with more warming in west and southwest and in Alaska, and less warming and even a little bit of summer cooling in some of those central and southeastern locations, such as Georgia, for example, or northern Texas. What is even more important when we are speaking about the temperature changes is really the increase of the temperature extremes. And what the data tell us that the frequency of cold waves has decreased since the early 1900s, but the frequency of heat waves has increased, especially since the mid-1960s. In any case, the Dust Bowl era of the 1930s still remained the peak period of the extreme heat, so the extremes, the heat extremes that we have right now, they are still slightly less than what the United States saw in 1930s, but we also expect these events becoming more and more frequent. And then the number of high temperature records set in the past 2 decades far exceeds the number of low temperature records. And you have probably noticed even it's during your own life in Michigan, right? We see more and more of those extreme high temperature records, but our cold extremes, yes, we experience them, but they're definitely not as dramatic. So this graph shows us pollen-based temperature reconstructions for the temperate North America, mainly the United States and Canada. And the blue curve shows us the pollen-based reconstruction of the 30 years average. The red curve shows us the corresponding tree-ring-based data, average also reconstruction. And they're also smoothed and used to calibrate the lower frequency pollen-based estimates. And so you can clearly see that what we have experienced in the past century looks very different from natural variability that we see in the pollen data and in the tree ring data over the previous centuries. So these maps and these graphs are also very interesting. So what you see on the left side is the change in the coldest temperature of the year for the 1986 to 2016 average minus 1901 to 1960 average. And everywhere we see those red dots, right, the more intense is red, the higher is the difference, and then the blue dots to show the lower difference. So almost everywhere, if you see almost everywhere around the United States, especially in Pacific Northwest, in parts of the Midwest, in New England, you see this very significant shift, very significant change in this variation. And then at the graph below, you see the behavior of the coldest temperature. On the right side of the graph, you see the change in the warmest temperature over the year. And again, it's the difference between what we saw in 1986 to 2016 average minus the average for 1901 to 1960. And so again, you see here different pattern, right? In this case, the warmest temperature, we actually see lots of those blue dots, especially on the eastern side and the central part of the United States. And then the graph below also shows you the variability of those warmest temperature all over the United States. This is another way to see at this data. So this graph shows us the record highs and record lows in the United States. And as you look at the variability of the temperature all the way since 1930s through where we are right now, you can clearly see that in the past we had some daily record highs and daily record lows, and there was some variability, and little by little we see more and more of those daily record highs. But it's really, especially since the beginning of this century, especially the past 20 years, maybe past 30 years, we see huge spike, huge increase of those daily record highs, and clearly, especially past few years, set the records very high. As we spoke before in the previous lectures, you remember that climate change means different things for different areas. So it's not just about progressive warming. We see changes in the temperature. We also see changes in precipitation. And for different parts of the United States, we have different implications. So for example, with the temperature, we already saw that some states, some parts of the United States warm significantly faster than others. For example, we see very fast warming in Alaska. We see very fast warming in northern Michigan, in northeastern states, for example, in Maine or in Massachusetts or in upstate New York. On the other hand, we see much more moderate warming or even no warming in some places in the South, such as in Georgia or in Alabama and Mississippi. For many areas, we also see very significant changes in precipitation. And with precipitation, it's more complicated because, as you can see, here in Midwest, we see dramatic increase of total annual precipitation, and especially precipitation extremes. Here in Michigan, our observed change in the total annual precipitation falling in the heaviest 1% of the entire rainfall event has increased already by 42%. So no wonder we're experiencing more flooding, we're experiencing more really unprecedented rain events. And you all have probably noticed it in the past few years. If it rains, it really rains. On the other hand, in American Southwest, we actually see the decline of the precipitation. So not only we have less heavy rain, we have less rain in general. And you know that in the past few years, states like California and Colorado and Nevada that are already pretty dry, they have experienced more and more droughts. Now, so far, we have been looking at the changes that are already recorded, what we know from either meteorological observations on the ground or from the satellite data together. Now let's see what models tell us about what we should expect in different parts of the United States. And you know that the models are pretty consistent with observations. You all remember that we can validate the model by checking them against the real meteorological observations. We can always run the model backward and see if they agree with real data or not. So the models are pretty consistent, and there is also lots of consistency among the models themselves. The model average can give us pretty accurate picture of what we should expect in the near future in the United States and worldwide. So the models tell us that the annual average temperature over the United States is projected to rise pretty much everywhere. Just like with observations, it's not going to rise at the same pace and at the same rate everywhere. And we will see much more warming in some areas and less warming in others. Overall, the increases of about 2.5 degrees Fahrenheit, which is about 1.4 degrees centigrade, are projected for the period till the middle of the century. And we see this increase under all RCP scenarios, but of course you are all familiar with RCP. RCP 8.5 is going to give us much higher warming compared to, let's say, RCP 4.5, right? So it all depends on how high would be greenhouse gas emissions, and this depends, of course, on our policies. So you can see that we'll see much larger rise by the end of the century. So this is where we should expect somewhere 2.8 to 7.3 degrees Fahrenheit in the lowest scenarios in RCP 4.5, and we can expect much higher increase all the way up to 11.9 or maybe even higher in the highest scenarios such as RCP 8.5. So this is how actually this numbers looks on the maps. What we see here on top of the slide, the projected changes in the annual average temperature for the middle of the century under the lowest scenario, RCP 4.5 versus highest scenario, RCP 8.5. And then at the bottom of the graph, you see the difference between these two scenarios all the way through the end of the century. And this is quite consistent with what you have probably observed in the Lab 1 and then in the Lab 3 when you used Magic's engine. Just like with the temperature observations, with the temperature scenarios, we are much more concerned with the temperature extremes rather than with the absolute values, and the extreme temperatures in the United States are projected to increase even more than the average temperatures, just like we saw from the past. So the temperatures of extremely cold days and extremely warm days are both expected to increase. However, cold waves are projected to become less intense and also less frequent, while the heat waves are expected to be more intense and also more frequent. The number of days below freezing points is also projected to decline, while the number of days above, with the temperature above 90 degrees is expected to increase. So this is how this information looks on the maps of projected temperature extremes. What we see here are two sets of maps. We see projected change in coldest temperature of the year by the middle of the century, and the changes in the warmest temperature of the year by the middle of the century on the top of the graph. And then at the bottom of the graph, you see the mean of three warmest models for the projected temperatures, and then the mean of the three warmest models for the warmest temperature of the year. So there is a little bit of variability of what different models tell us, but they are pretty consistent. They all tell us that we are going to see, we are going to experience higher temperature increase during winter. We're really losing our winter. If you look at Michigan, we are clearly places like Michigan, like Wisconsin, Minnesota, places such as upstate New York, we are losing our winter much quicker than we are gaining some temperature in summer. And this is how it looks in terms of increase. So the projected changes in the number of days with a temperature above 90 degrees by the middle of the century. You can see that they're going to increase quite significantly under RCP 8.5. And then we also see here the projected change in the number of days below 32, some winter extremes. And clearly the major concern is the increase of the heat waves rather than the increase of these extreme cold events, even though we also see some of these cold extremes being continued. And at the bottom of the graph, again, you see the mean of the three warmest models for both projection of the number of days with the heat waves that are defined as the number of days above 90 degrees, and then the number of days of cold spells, so cold waves, with the temperature below 32. Okay, so why this is important? Because those heat waves and cold waves, they have significant impact on our health. And here are some projections and data for the heat-related illnesses and death. We know that when people are exposed to the heat wave, the risk of their cardiovascular diseases, strokes, heart attacks increases quite significantly. And so this is what we see from the health statistics, the data for 1964 through 1991. We also see the projections from the model for this year, for 2022, that we can then compare with the real medical statistics. And then we see the projections through the middle of the century by different models through 2050. Because the heat-related illnesses and death appear to be related to the temperature much hotter than those which the population is accustomed, cities would experience extreme heat, would be particularly vulnerable. And this is particularly true for the cities in Midwest, or in the Pacific Northwest, or in the East. You can see that those cities that already have been experiencing those heat extremes, places such as Los Angeles, for example, or Atlanta, they will see some increase of vulnerability, but not as much as places such as Chicago, like New York, or Minneapolis, or St. Louis. So those places where population is not really accustomed to the heat waves, like here in Michigan, the risk of exposure is significantly higher. And this is both because we are not accustomed, we don't have the same behavioral adaptations, but also because our infrastructure, the infrastructure of our cities, is not really adapted to those heat extremes in the same way as, let's say, cities in the South. Here is another area of concern, which is also associated with weather extremes related to climate change. And again, it's particularly affected Midwest and Northeast, and to some degree cities in the Pacific Northwest. As we see more and more flooding, we should expect more water and foodborne diseases due to those extreme flooding events caused by precipitation extremes. Wastewater systems that combine storm drains, sewage, and industrial waste are still used in many older communities, especially in Northeast and in the Great Lakes regions, where we have many relatively old cities, right? And these old cities have old infrastructure. So during rainstorms or spring snow melt, when the volume of water is discharged which is discharged in our lakes and our rivers, and it significantly exceeds the capacity of the sewage treatment systems. These systems are becoming overwhelmed, and so they are not really designed for the overflow that we start experiencing more and more. And so as a result of this, all this untreated sewage and pollution and industrial pollution is going into the surface water and underground water, and so it can lead to really major water contamination and lead to epidemics, foodborne diseases, and so on. And of course, right now we are already experiencing global pandemics with COVID-19, and it kind of shows you, just as a reminder of how vulnerable is our society when the capacity of the system is exceeded by the impact either of climate change or any other stress. Here is another thought about potential implications of climate change. Temperature increases in different parts of the United States. We see from epidemiological data that in the past years, we have seen an increase of many vectors, such as mosquito and tick and rodent, and those vectors carry various diseases, for example, West Nile virus and dengue fever and Lyme disease. And adaptation is going to play a very important role as we are trying to understand how temperature increases and temperature increase, and to some extent also moisture and precipitation increase affect both behavior of different viruses and different bacteria, and at the same time they also affect their behavior of the vector. So here you see the occurrence of cases of dengue fever in the border states, along the border of the United States in Canada and Mexico, and you see the number of cases in Texas lower, significantly lower than Mexico. And so you might think, well, like if we close the border, that's the solution. But it's actually not the solution, because mosquitoes are flying over any kind of borders. So we need to think about collaboration. We need to think about better infrastructure. We need to think about different countries working together on how we can improve quality of life of people on both sides of the border. So with this, we have completed Unit 1, Lecture 5. And I have a couple of review questions for you. So I want you to reflect on your own as you're working with the readings, how climate of the United States has changed during the recent past and how it is expected to change in the 21st century. Again, consider working with both reports and jotting some notes and really using my lecture just as a guidelines, but finding more information in the report and reflecting on this data. And then the second question is, what are potential negative implications of climate change on the economy, infrastructure, health, and human well-being? And I gave you some snippets through the lecture. And again, you have much more information available in both reports, and I encourage you to work on your own pace with both readings and then take notes and use your own examples. Okay, and we have completed Lecture 5, and I will see you on the next slide. Our next lecture in this unit are the impacts of climate change on the United States ecosystems and biogeography. You have several readings associated with this unit. They're all available online. So again, we are working with the same two reports, the science report by the National Climate Assessment on Science of Climate Change. So this is chapter 10, focusing on the US ecosystems. And then the second volume on the effects of climate change on the US, focusing on impacts and adaptation. And here we are reading chapter 7. And I also encourage you to read the report by the United States Department of Agriculture that was published in 2014, which is focusing specifically on impacts of climate change on the US ecosystems from the perspective of agriculture. So you all probably realize that ecosystems are sensitive to changes in the global surface temperature. They are also very sensitive to precipitation patterns. And finally, they are sensitive directly to the atmospheric carbon levels because all plants use, or almost all plants, use carbon as food through the process of photosynthesis. So there are really two ways how climate and ecosystems interact: through temperature and precipitation patterns, and through the rate of photosynthesis, which is controlled to some degree by concentrations of carbon in the atmosphere. So just like we use climate models for understanding and predicting climate change, we can also use other types of models such as biogeochemistry models and biogeography models in order to understand how climate change is changing and how it's interacting with our ecosystems. There are two different types of changes that occur in ecosystems as a result of climate change. These are changes in the biogeochemistry, for example, changes in the carbon cycle, nitrogen cycle, the rate of photosynthesis, the rate of absorption of carbon from plants to soils, so the release of carbon from soils into the atmosphere. So all these changes in the biogeochemical cycles, they can be examined and predicted by the near-term changes with biogeochemistry models such as, for example, Biome, BGZ, or Century, or TAM, terrestrial ecosystem models. Some examples of these models are available in the folder in the Blackboard, and I encourage you to read about these models and experiment a little bit with them. And Century model is actually available for download, so you can play around a little bit with these models, but this is by no means not required. Changes in the biogeography are more long-term changes, essentially showing how the map of ecosystems is changing with time as a result of temperature changes and precipitation changes. And so these changes can be understood and predicted with biogeography computer models, and some examples of them are LPJ and MAPS, which stands for Mapped Atmosphere Plant Soil Systems, and MC1, which is another dynamic models that can be used for understanding those long-term biogeography changes. Essentially, when we speak about biogeography models, you can think of them as GIS maps, showing you how the entire geography of our ecosystems is changing following the temperature changes, precipitation changes, and other climate changes. So what kind of changes are happening in the ecosystems? Well, first of all, the geographic distribution of dominant plant species is changing. So the entire ecosystem is changing, but also the structure of the ecosystem is changing. The dominant plant is changing, but also what is dominant? The competition among the plants is changing because some plants can adapt much quicker and much better to other changing concentrations of carbon dioxide or temperature changes or precipitation changes, and other plants potentially can disappear, and so the entire food chain in the ecosystem is changing. It also affects not only plants, it obviously affects wildlife, which depends on those plants. Other changes include the plant productivity. We might still see the same plants, but we might see higher biomass or lower biomass. The biodiversity changes within the natural system. As I said, some plants would take advantage and benefit from climate change, and others might disappear as a result of the competition. Many basic ecological processes are going to change. So, things such as pollination, reproduction, migration, and so on, they all are changing within the system. And then there are many ecosystem climate feedbacks. So we're usually thinking about how climate is affecting ecosystems, but as ecosystems are changing, there is this feedback, and ecosystem is contributing to climate change. We spoke about feedbacks in the past, for example, in terms of the methane release from thawing bogs and swamps in Siberia, in Canada, in Alaska. But there are many other positive feedbacks of this type. For example, if climate change is leading to increase of droughts in the area, this drought can lead to less and less vegetation productivity. So we're going to see long-term less and less vegetation, and as we're going to see less and less vegetation, there will be less moisture available for evaporation and formation of local clouds. And so this ecosystem change is going to lead to further local climate change, is going to make climate even drier. And then the feedback is going to continue. So it's kind of the typical example of positive feedback when drought is leading to depletion of vegetation, and then depletion of vegetation is causing more drought. So if you go to the Blackboard and if you check the folder that contains some examples of biogeochemistry models and biogeography models, you would actually see that biogeochemistry models are very useful because they help us to understand what are the immediate impacts of climate change on ecosystems, because they help us to see what would be the changes in the carbon cycle, or in nitrogen cycle, or in cycle of sulfur and phosphorus and other nutrients, and how it's going to influence the distribution of water in the ecosystem, how it's going to affect how the ecosystem is going to be influenced by temperature, precipitation, solar radiation, soil texture, what will be the concentrations of carbon dioxide in the atmosphere, and how they're going to influence the uptake of carbon by the ecosystem. How much carbon is going to be stored in vegetation, how much is going to be stored in soils. Will we see more biomass or less biomass as a result? So the outputs of the models help us to estimate what will be the future net primary productivity of the ecosystem, or what will be the storage of carbon in vegetation or in soils. The biogeochemistry models give us fairly short-term scenarios. They are looking forward at the period of around 20 to 30 years, and in general, although there is some moderate disagreement among the models, they suggest that we should expect to see the increase of net primary production throughout the United States. This increase of net primary production is primarily going to be caused by the increase of concentrations of CO2. So because plants are taking CO2 through the photosynthesis, the CO2 has fertilization effects on plants, but it affects differently plants with different photosynthesis pathways. So there are C3 plants, C4 plants, and CAM plants, and they all take CO2 through the different pathways. So on average, we expect that CO2 fertilization is going to lead to increase of the net primary productivity. If the models were not taken into account the CO2 fertilization, we would actually see less vegetation, because it's becoming harder for plants to cope with those temperature increase. So in general, the climate change itself has negative impact on ecosystems, but the CO2 fertilization might have modest positive impact on the biomass. And so as a result, we should expect increase of biomass in some plants, but probably decrease in some others. Models right now disagree, so it all depends on how the ecosystems are computed, because obviously we cannot absolutely accurately compute the response of every single species, and the dynamic of species is changing very quickly. So we'll see some disagreement among the models, but overall they all suggest that there is some degree of fertilization effect. Biogeography models are looking more at the long-term changes through the end of the century, and so they are driven by climate models. For example, in this experiment, 3 biogeography models from different institutions were used, and they were driven by the outputs from Hadley model, the HuntCM model that we used in a couple of labs in Magix Engine, and also one of the CCM models, right? One of the versions of the Canadian climate model. And so they are looking at the geographic changes in the species and the entire ecosystems through the United States. So the biogeography scenarios through the end of the century suggest that the northeast of the United States is going to experience increase of the woodland. There will be also some changes in the mix of the forest. We will see forest, but it's just going to be different forest made of different species. In the southeast, the forest mix is also changing. Again, some species are taking advantage of climate change and others are disappearing. And we are also likely to experience the expansion of savanna and grassland at the expense of forest. So see this move of savanna ecosystem kind of shifting north. Here in Midwest, also the mix of forest type changes. Many of you probably have heard before that the white pine, which is the state tree of our state, Michigan, is going to disappear. It's moving to Canada, it's moving north because Michigan is becoming too warm for it. Also, we are going to see some modest expansion of savanna and grassland, especially in the southern parts of the Midwest. In the Great Plains, on the other hand, it's interesting, we are going to see already, and we're already seeing some increase of woodiness. So what is happening here, scientists think that it's the result of CO2 fertilization, and we see this enroachment of shrubland and small trees in the areas that has been occupied by grassland in the past. In the west, we see in some areas the desert being shrinking and also expansion of those shrublands and dry forests, also most likely as a result of the CO2 fertilization. And then in the northwest, we actually also see slight increase of forest growth. So if you are interested, you can go into the box with biogeography models and biogeochemistry models. You can also, I advise you to look at the link on the Blackboard with information about FACE. And FACE is the free air carbon enrichment facility, and those experiments help us to see how vegetation, how the entire ecosystem is changing when it is exposed to higher concentrations of CO2. With this, we have completed the next lecture, lecture 6 in this unit, and I would invite you to reflect as you are following all the readings. I would like you to think about these 3 questions. In what ways changes in climate affect ecosystem changes in the United States? And I hope that as you are working with all these 3 reading sources, you are going to look at some examples beyond these lecture notes. Also, what is the purpose of the biogeochemistry models? You can find more information in the folder on the Blackboard. And what is the purpose of biogeography models? Again, you can experiment with these models and look at the maps and look at the scenarios. Our next lecture in this unit is focusing on the socioeconomic context for climate impact assessment. So this is really more, it's not a lecture, it's more the sequence of discussion, questions, and opportunity for reflections. It's also based on Volume 2, Impacts, Risks, and Adaptations in the United States from the National Climate Assessment. And I invite you to follow with the report and look at the assigned chapters and also go beyond maybe the assigned chapters as you are reflecting on some of my questions. So we all know that climate has huge impact on our life, not only climate change, but just climate, even when it's relatively stable. and climate has very different impact on lives of different people. We spoke in the past about vulnerability and the ways how difference in exposure, sensitivity, and adaptive capacity makes different groups of people more or less vulnerable. So that can be related to age and health conditions and education and, of course, material assets, your infrastructure, your income, your access to information, and so on. All these can make you more vulnerable or less vulnerable to all kinds of adversities. And we see, again, all this playing right now as we are experiencing all over the world a huge impact of COVID-19. In many ways, the same concepts that we are learning about climate change also apply to the global pandemics. We already see huge ranges of inequalities that are linked to access to technology, income, food security, access to healthcare in different parts of the world, and also different groups of people within the United States. So this is just an invitation to think about how socioeconomic contexts influences climate impact and how it also influences impacts of climate change on different groups. So in this unit, I want you to think about multiple impacts of specific types of climate change, let it be temperature increase or precipitation increase or precipitation decrease or increase of extremes and so on, how all this is going to affect different aspects of our life. So why impacts of climate change matter to people? How climate change impacts our health, how climate change impacts our income, how it impacts our employment opportunities. Please take a moment to browse through the report. It's available also in the browsable form on the website of the report, and you would find the link on the Blackboard and also in this lecture and in the syllabus. And think about how climate change has an impact on price or availability or quality of various goods and services. What are the impacts of climate change on property values? What are the impacts of climate change on property losses? Should we expect changes in the real estate market, for example, as a result of climate change? How it's going to be better or worse? How it's going to affect lives of different people in different parts of the country? What are the impacts of climate change on the recreational opportunities in winter, in summer, in fall, in spring? What are the positive implications and what are the negative implications? So I'm inviting you all to think of your own example, and you can follow me with the report, or you can come back to those questions later. Again, I want to come back to the same analogy between some unexpected impacts of climate change and what we're experiencing right now, what we're experiencing as a world in this pandemic of coronavirus. And there are obviously many uncertainties regarding our vulnerability to all these impacts and the role what the technology is going to play in helping us, but also making us both less vulnerable and more vulnerable to those future impacts of climate change and other adversities. And we all kind of in the same boat right now, and we're experimenting with technology. And I want you to think how the improvement of technology, how the technological changes can help us to reduce vulnerability to weather extremes and climate change, or maybe also, other problems such as global pandemics or problems with food shortages, food insecurity, but also how we have to be careful and how this technological development can sometimes make us more vulnerable as we're becoming more and more reliant on this technology. What happens when it doesn't work? Are we more vulnerable or less vulnerable when we are fully reliant on technology? Again, this is a big question, so don't expect the immediate answer, but take some notes, reflect, look at think about your experience this week, but also think about the readings. So here I'm going to make a little pause here and give you some time to learn more about Inside Climate News and its recent project, American Climate. So all these videos are very recent and they're all based on essentially the events of the past year or past couple of years, and they're focusing on impacts of climate change, such as forest fires and flooding and sea level rise. And so those are very short stories. They're kind of told from the perspective of people who have went recently through this experience. And so I encourage you to watch all these videos, or at least as many as you can. You can also subscribe for the weekly updates by Inside Climate News, and this is entirely optional. You can also find tons of information about climate change and lots of visuals on the website. So Climate News and its American Climate Project, a very good resource on climate change that I hope you will take beyond this class. So enjoy the videos, and then I will see you at your pace at the next slide. And this is the fourth lecture in this unit, and we would focus here on the impacts of climate change on Midwest and Michigan. And again, I see it more as an opportunity to guide your reflection and discussion. It's not really the lecture because you have all information that you need in these readings. So I want to remind that we are continuing to read the National Climate Assessment, and it is available on the Blackboard, or you can follow this link directly. And this chapter is going to bring you straight to the section on Midwest. And the next report, the report on impacts and adaptation, also you can jump straight on the chapter on Midwest, and this is chapter 21. If you follow this link, I also encourage you to look at the document that I put for you on the Blackboard, and it's also available here through the direct link. And this is the report that is focusing on impacts of climate change on Michigan, and it had been put by the University of Michigan. There are four major areas that are really important for Midwest, particularly for the upper Midwestern states such as Michigan. Obviously, water resources is a very big part of our economy, our culture, our geography. So the ways how climate change is impacting water resources is hugely affecting all aspects of our life, especially in the Great Lakes states. Agricultural ecosystems are also a very big part of Midwest, and our economic activity and our lifestyles and our food security. Impacts of climate change on natural and semi-natural ecosystems. We have here lots of forest, lots of managed forest. So again, this is a very important aspect of climate change for states such as Michigan, Wisconsin, Indiana, Illinois. And then quality of life, and of course quality of life is important everywhere, but we are going to focus here specifically of what are the impacts of climate change on well-being and quality of life here in upper Midwest. So let's start with water resources and climate change. Obviously, living here in the Great Lakes, we know already, we can observe, we can literally see each time when we come to take a walk along the coast of Lake Michigan that the lake levels have been changing very quickly, and so we see major profound impacts of climate change both on the Great Lakes but also many small inner lakes in terms of their lake level, but also in terms of the increase of eutrophication, the changes in the quality of water, the changes in our aquatic life. Also, we see less and less ice cover. There have been lots of variability in the past years. This summer, Lake Michigan essentially did not have ice cover at all, or almost not at all. We also see many concerns with stormwater routing. So Midwest has quite old infrastructure, and so we see lots of problems with routing this excessive stormwater to prevent contamination and kind of splashes of raw sewage or industrial waste into our drinking water resources. And finally, flood levels and floodplains. Midwest, West Michigan alone has experienced lots of flooding in the past years, and so this is an area of growing concern for all Midwestern states. So please follow this link to access conversation about floods and the way how floods are changing in Michigan and how they're becoming more intensive and also more frequent. And also think about what kind of urban planning changes, what kind of infrastructure changes need to happen in order to adapt to those aspects of climate change. Because it looks like we are still building infrastructure in our old ways as if floods haven't changed. The second major area of concern for Michigan and for other Midwestern states is, of course, impact of climate change on agriculture and food security. So on one hand, we are already experiencing longer growing season. That looks like a good thing because we can grow our food during longer period of time. We also see the increase of precipitation, and again, at the first glance, it might look as a good thing. However, you all know that not necessarily true because most of this precipitation is fallen during a very short period of time. So it really leads to soil erosion, it leads to flooding. Too much precipitation fallen during a short period of time is not good for plants. In the reality, it can kill them. And so this is exactly what we saw in the previous year. Our past few springs have been extremely wet, and so that creates lots of problems for Michigan farmers because this precipitation is not beneficial. Another area of impact, kind of indirect impact of climate change is the CO2 fertilization effect. And so here again, there might be some positives and negatives. When we have more CO2 in the atmosphere, it can be actually beneficial for some plants, but it is not beneficial for others. And so farmers really need to adjust, and farmers already have done so many adjustments, experimenting with different species, because as we see higher concentrations of CO2, it also causes invasion of many C4 plants. So C4 plants, such as crabgrass, for example, many of them are invasives. They can take advantage of higher concentrations of CO2. On the other hand, our native grasses here in Michigan are C3, and they don't necessarily benefit from those higher concentrations. So we see that our grassland cover is changing very quickly. But also many of our crops are changing, and we need to think about different combinations of crops to see what can actually grow and thrive under those higher concentrations. So our agriculture would never be the same as we're experiencing all those changes. And of course, these natural and semi-natural ecosystems, they provide lots of recreational opportunities. They provide many important ecosystem services. So as we are anticipating all these changes, we need to think about the implications for fish and fishing, implications for wildlife and the way how we manage our wildlife, implications for wetlands. And wetlands are extremely important for protecting our water from pollution. They're extremely important for our agriculture, for the quality of life. And they're really facing two simultaneous threats. On one hand, they're shrinking as a result of landscape fragmentation and urbanization. On the other hand, they're also increasingly impacted by climate change. And we are also seeing more and more invasive species again because of this upset balance between the C3 plants and C4 plants. And C4 plants are those plants of tropical origin that can take better advantage and adapt to higher concentrations of CO2 and also higher temperatures. In terms of impacts of climate change on the quality of life here in Michigan and in Midwest in general, I want you to think about two aspects of this. One is, of course, human health and well-being, and the second are recreational opportunities. So here we have many seasonal sports. Michigan is also important tourism destination. Tourism is a very big part of our economy. We have many local festivals that are associated with different plants or different crops. We have cherry festival, tulip festival, asparagus festival, many other festivals that are associated with specific plants. And these plants are impacted of climate change. So, just I want you kind of to think if you have ever visited, for example, Tulip Festival in Holland, which is really, symbol of this city and symbol of the heritage of West Michigan. So as we see changes in the seasons, in the timing, in the adaptation of different plants, like how each of those festivals is going to change and how it's going to impact our local cultures. Our recreational opportunities obviously are already changing. We see much less cold season recreational activities. I don't know how many of you enjoy skiing or snowboarding or snowmobiling. So I am really very passionate about cross-country skiing. And this winter I was able to go skiing only twice, and I used to go skiing every weekend at Pigeon Creek. And this year, we almost didn't have any snow. So for me, it might mean just changing my habits of recreational activities, but for the small business owners who have been reliant for generation on those skiing resorts, this can lead to pretty major changes in the livelihoods. On the other hand, we see more opportunities probably for more warm season recreational activities, some water activities, but this can also work both ways. And again, I want to invite you to think about, what it can mean for warm seasonal recreational activities. On one hand, we might have more warm days. We also have more heat waves. We also see more mosquitoes. We also see significantly more violent precipitation events. So how it's going to impact, those recreational activities such as golf or water sports or, beach activities and so on. So again, work with the readings, consider discussions, you can do the online discussions with each other, and let's just brainstorm, how our recreational future looks here in Michigan. So I found this interactive story online by Sam Stevenson, who has really put together a very nice interactive story about the effect of climate change on Lake Michigan beach towns, and he's particularly looking here at Grand Haven and some other places. So take a moment, kind of walk away from this PowerPoint and look into those changes that have already taken place in Lake Michigan between early 2000s and what we should expect by 2076. I found that it was extremely well done, put together very well on Satori, and it's just a great example of how you can put visually this information through the story. And another important aspect of this is, of course, implications of climate change for human health here in Midwest and here in Michigan. We know from the data and from climate change scenarios that we are experiencing milder winters, so it might be good to some extent that we have less cold-related mortality. On the other hand, we have more flus, more other viruses, and of course, this is the time when we are all very, very concerned everywhere in the world about outbreaks of very dangerous viruses like the one that we're experiencing right now. And we don't know how these viruses are going to affected by temperature changes. For example, right now everybody is hoping that hotter summer, when we have hot temperature in summer, this might help with COVID-19, but many scientists already are telling, hey, no, not necessarily, because we see that right now in warmer areas is just as bad as here. So hotter summers doesn't necessarily mean less viruses, but it also can mean more heat-related mortalities and more vulnerability, especially among older people, to cardiovascular diseases. Also more respiratory problems, because as we are experiencing warmer temperature and more vegetation changes, we see more pollution, but also more allergies. People with asthma, people with respiratory problems related to allergy can be particularly vulnerable to climate change. And we are also seeing increase of flooding everywhere in the Midwest, especially here in West Michigan. And so we really need to think about the implication of this on our waterborne diseases and foodborne diseases, and this is another huge issue for us. And here I want to encourage you to read and listen another article by Michigan Radio, 5 ways how climate change already impacts human health in Michigan.